Hi, everyone. Welcome to the latest installment of our new editorial webinar series, Coffee Talk. Each hour-long, information-packed episode curated by our editors features the insights and observations of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, Sysdig, pioneering provider of cloud-native runtime threat detection and response solutions. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief in the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is security and containers, understanding how it all ties together for enterprises. Before we get started, a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. We'll take some time at the end of each presentation for some questions. Please feel free to type your questions into the Q&A box at any time. We'll do our very best to get to all of them. Our sponsor, Sysdig, has provided some extra resources that can be found on the right-hand side of your screen. Be sure to check those out. And as a small thank you to all of the attendees who stick with us to the end, we'll be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now I'd like to welcome our lead presenter, technologist, creator of compelling content, and senior resultant, Howard M. Cohen. In his 40-plus years in the IT industry, Howard has held executive positions in many of the top channel partner organizations, and he currently writes for and about the IT channel. He is a sought-after speaker, an insightful observer of the technology landscape, and one of our favorite presenters. Take it away, Howard.
Thank you, John. Thank you very much. And hello, everybody. Welcome to today's presentation on containers and security. Given the rising popularity of microservices and containers, this is a very timely subject, and we're looking forward to hearing a lot more about it from our sponsors at Sysdig later today. Meanwhile, those of you who've joined us before know that I like to start each session with a word of the day. And today's word is cloud native. Cloud native. Cloud native is an environment in which we create software written in the form of microservices, a collection of microservices, each one stored in a container that moves around the cloud network effortlessly. And then we employ a DevOps methodology to achieve continuous delivery with the hope of achieving continuous improvement, both to the software and to the products and services the software supports. So cloud native is very exciting, but perhaps the best way to define it and to illustrate it would be by comparison to what came before. And this is not an ad for 2001: A Space Odyssey. This is simply a photograph of a monolith, because we now refer to the old way of producing software as being monolithic. That is, it creates one big block of code. Each software application is written as one big continuous block of code that contains every function, every subroutine, every process that's needed to do what the software is meant to do. Now, of course, the challenge with this is if everything's in one block of code, if anything goes wrong, it could bring back down the entire block of code. That is, the application could fail, and everybody using it could find themselves with nothing to do for a while they figure out how to get it back up and running. This is, of course, not acceptable. And so we've evolved into a new way of creating software. Instead of one big block, one big monolith, we create the software in the form of small individual microservices, each one a part of what was done in the monolith, but each one standing completely alone, and so bye-bye monolith. Now, each of these microservices is put into a container, along with all the resources that it will need to do its thing. Why? Well, very simply, this container can very easily be transported around the cloud network, from cloud to cloud, from server to server, from serverless environment to serverless environment. wherever it's needed to do whatever it's needed to do. Each microservice is instantiated in its container when it's needed and gets sent to where it has to do its job. Now, if a microservice happens to have a flaw, if it's broken, if something goes wrong, that microservice is instantly discarded and reinstantiated. A new one's created to replace it. That means that only that little thing is delayed infinitesimally. I mean, you can't even tell that it's been delayed. Meanwhile, the entire rest of the application is running happily. This is a whole new level of resilience that couldn't be achieved with monolithic software. Each container has a life cycle and exists within a specific kind of environment. And what I'd like to do now is to review that entire life cycle with you and talk about the security requirements at each level. Now, looking at the list, the first thing you're going to notice is that there's no listing for security. Security is just not there. Well, this is very similar to a model many of you should be very familiar with. It's the famous 7-layer model of networking. Officially, it's the International Standards Organization Open Systems Interconnect model. It's the ISO OSI model. We all refer to it as the 7-layer model. And people have constantly asked me whenever I present it, where's the security layer? Well, my answer to that question is yes. That is to say, every layer has security built into it. You need security at every layer of the 7-layer model. Security is a chain that's only as good as its weakest link. Each of these layers, it can be considered a link in the chain. The same is true for the container lifecycle environment. The container has to be secured even before it's created and right on to the moment where it's done its job and it's destroyed. So let's take a look through that life cycle. Let's go through the sequence and see how security impacts us at each level. At the first level, the first place that bad actors have an opportunity to hurt you is by compromising your development tools. You haven't written a stitch of code. All the rest of the members of your team who are all working on other microservices, they haven't written a stitch of code. But somebody cleverly breaks in and compromises your tools. Those tools can easily convey malware right into anything you create from that point forward. So here we are before the beginning, and already we have to be careful. There's an old saying, give us a job and the tools to do it, and we'll mess up your tools. Well, that's what's happening here. And so we start being careful before we even write stitch one of code. They can also insert malicious code into your source repositories. That is, as you're building your code, you're going to keep it in a source repository, somewhere where you can go back and get it, continue development of it, and continue working on it. Meaning that, again, another step along the way, those bad actors are out there and they have an opportunity to attack you before you've even gotten anything written. This is referred to commonly as a software supply chain attack. They're basically attacking your supply chain, the pieces of code you're working on to eventually create a microservice that is part of your overall application. From our perspective, if this does happen, and let's face it, there is no perfect security, so even though we may do the best job we can of securing our tools and our repositories, it is possible that something may get in, which means that we have to catch it. We have to scan it and screen it and look for it and make sure. We have to always be suspicious that somebody's gotten in and hurt us already. You've heard of zero trust. Zero trust is here in abundance. trust nothing, trust nobody. You have to catch it before the code is used to build containers. First and foremost thing to do, though, is to implement access controls for your development tools. That is to say, protect your development tools with multi-factor authentication and Active Directory services and everything you can do to make it as close to impossible for bad actors to get into your tools as you possibly can. This includes enforcing the principle of giving each person as little access as possible. Give them rights to whatever they need, give them privileges on whatever platforms and engines they need, but nothing more than that. And I'm going to probably repeat this over and over and over again. Always scan your source code for malware before you build any containers and ship them anywhere. We're going to be doing a lot of scanning. Okay, now let's talk about the application code itself. And of course, malware, I've thrown the word out a couple of times now, but just by way of definition, it's malicious code. It's a little piece of code that does something you don't want done, and they snap it into your code, so it's executed even though you don't want it to be. As we said earlier, you have to protect your source code repositories at all times so that nobody gets into the code while it's in development. And you have to scan all source code before you ever use any of it to create a container image. While we're on the topic of container images get packaged. That is, there is software that creates a file containing all the instructions necessary for the building or the instantiation of a container with the microservice you want and the resources you want within it. That's referred to as a container image. These two are very vulnerable. Okay, so yes, all the application code, all the resources are in there. One thing to watch out for, not only is your code in there, not only are your resources in there, but many developers make use of resources that are available from third parties. It's just like anything else we do. There's always third-party software, third-party libraries, third-party source code that will help do what we need to do. We don't need to rewrite it. We simply obtain it from a public repository, a publicly available repository, and we include it. Well, on the way in, there's that magic four-letter word again, scan. We want to scan it on its way in to make sure, no matter where it comes from, that it doesn't contain any malware. Do not trust any, even the most popular public third-party repositories cannot be trusted, not because they're horrible people, but because this is the world we live in. There are always people looking for advantage, always people looking to hijack your stuff. Now, one thing to know, because you are going to be scanning these containers, is that none of the available container scanners are foolproof yet. This is, we're pretty new in this, and there's development going on all the time. So very soon, I'm sure, I'll be coming back to you and reporting to you that, hey, there are now container scanners that really do perform a complete and total job. It's not the easiest thing in the world to do, but the developers are on it, and hopefully we'll see more than just identifying the most known threats. This has the same problem as any security software, the zero-day threat, the signature we haven't seen yet that can't be recognized. It's new. So be aware that this is an area of vulnerability that you have to practice as much care as you possibly can. Once a container is created, it's stored in a registry so that users can obtain them readily from the registry by lookup. Obviously, the users themselves are not doing this. The orchestrator is really doing this, but again, it's making the code, making the container image available so new containers can be instantiated and sent out to do what they're supposed to do wherever they're meant to do it. the registry is another place that must be strictly protected with powerful access control. You don't really need a whole lot of people accessing your registry. Developers need to put their new container images there, but you don't need people pulling things out all the time. Whoever does need it, give them access. Whoever does not need it, make it as difficult as you possibly can for them to get at your image registry, your container image registry. Also, and here's where I think a lot of us fall down in a lot of places. We're all prone to clutter. Most developers are inveterate pack rats. We hold on to everything. So here in the registry is not a place to be. What you want to do is regularly audit your registry to find earlier versions of containers that have been replaced by updated containers. Get them out of there. The fewer images you have in your container registry, the smaller your attack surface is. So you really want to get them out of there. Set a date monthly, if you will, to just take a quick audit and see if there's duplicates, see if there's old versions and new versions. And again, we talk about these third-party registries. Any images that you hold on to, they've got to be considered suspect. You have to inspect them carefully. You have to scan them. You have to believe deep in your soul that they're going to hurt you, and then prove to yourself that they will not. Of course, all of this takes place in a network environment. Your cloud services are all connected to you through a cloud network. And so every node that's using your containers, they're all there. They're all connected to your network. They each have their own operating system. They each have their own configuration. The servers similarly have an OS. They're all configured. The storage, any other element that is on that network with your containers, and this is not strictly limited to a container environment. In any environment, you want to make sure your OS is hardened, no matter what device it's supporting. So make it a practice to always, double, triple, and quadruple check how hardened your operating system is so that nobody can get into it if at all possible. Another thing that's recommended in container environments is the classic intrusion prevention system. They also recommend that you're using microsegmentation tools and containerized next-gen firewalls. There are now firewalls that were designed for a container environment. So bringing all of these tools to bear in your network will protect your containers in transit and as they're being used. So you want to keep the communications to a minimum and direct everything to where it needs to go and keep it away from prying eyes as much as you possibly can. This, of course, requires orchestration. And orchestration is a very important part of using microservices in containers when you build cloud-native application environments. Of course, just like everything else that we've seen so far, your orchestration system requires strong access control. You don't need anybody getting into your orchestration that shouldn't be there. It's an ideal place to make everything haywire because orchestration is the process of making sure everything goes where it's supposed to. So all they have to do is change that, and it goes where it's not supposed to. Again, the first line of defense, no surprise here, is identity and access management. People need to prove not only that they are who they say they are, but that their device is what it says it is and is cleared to be used on your network. It must be interrogated by your network access control. Again, least privileged access prevails here. You don't need to give more privileges, more rights to anybody other than what they need to participate in the orchestration of the containers moving around your cloud network. So carefully analyze what rights does each person need, and only give them those rights. Also, many different elements within the cloud-native environment, including the pods that are used to sequence many of the containers, they communicate with each other to coordinate activity. If an invader managed to get in there, they can move from pod to pod just like everything else moves from pod to pod, giving them incredible lateral freedom to move about your network. And let me tell you, you don't want anybody having lateral freedom to move about your network. It's perhaps the most insidious threat because they can affect everything. Okay. I would be remiss not to mention the fact that obviously there's always at least one host functioning on the network that provides all the services that are needed to move everything where it needs to be and do what it needs to do and coordinate runtime and everything else. Whichever OS you use must be one that is optimized for host operations and hardened for secure host operations. This is the heart of the system. You need to protect it like it's the heart of your system. Again, in identity and access management, least privileged access, that has to be practiced at every layer. Constantly scanning the host and its connections to the network for potential threats. Those of you who have not used threat hunting, this is a good time to explore it. You want to hunt for threats before they get to your cloud-native environment and impact your cloud-native applications. And then finally, the runtime environment, where the container actually gets to do something. Unfortunately, I need to advise that the runtime environment is currently the toughest part of the container stack for you to secure. The fact is that currently available scanners weren't designed to look into containers. That's just not what they were designed to do. Most of them were designed far before the introduction of containers. So they can't see any potential threats that may have made it through all of your scans. I want you to think about that for a moment. Think about how many times you have scanned every element on its way from idea to source code to container image to container, and then finally getting to runtime. You scanned it many, many times. We still believe threats can get through. And unfortunately, at this point, the current runtime scanners are not yet everything they can be. Again, if you've lived in this industry long enough, you know that a statement like that doesn't last long. And there's development even today on runtime scanners that do a better and better job. And soon, I won't be able to say this in this presentation any longer, which will be great. However, you can observe the behavior of an application, of a microservice, after runtime has occurred. Now, yes, that's after the fact, and that's not when you want to do it. But this is very similar in performance to the way in which ransomware works. When a phishing email comes in, there's really nothing you can do to assure that a user will actually recognize that it's a phishing email. Most often, they'll think it's genuine. They'll think it's from who it says it's from. And if it invites them to click a link or open an attachment, they'll do it. And then, of course, they open the doors to all kinds of horror. But the same thing is true here. You can't stop it because users can't be controlled the way that digital devices can. Well, here, containers can't yet be scanned or controlled as well as we would like them to. So we have to look at them after the fact. and we can compare their behavior to what we expect as a baseline, what we expect the behavior to look like. If it looks malicious, it may be, and therefore we can take further steps to ward off the effects of that malicious activity. And so now we've gotten to runtime. Everything is running. We're doing our best to identify when something may have made it all the way to runtime, which, again, it's not a good bet. Seldom does something make it all the way to runtime through all those scans you're performing at all times. Now, however, it's time for us to monitor our environment and manage our environment. And this is where the ongoing portion of the life cycle, this really should never end until that application is retired. So I can't express strongly enough how consistently these networks that contain microservices running in containers, how closely they have to be monitored. Anything can represent an anomaly, and they have to be managed proactively. Fortunately, there are many different kinds of tools available. There are incredible platforms emerging, and you'll be hearing about some of that today. But meanwhile, before we wrap up, I would like to go back to our word of the day and just go a little bit beyond monitoring and management to talk about the fact that, as we said at the beginning, microservices and containers are generally employed in a DevOps environment. Actually, the two really should not be used without each other. They go hand in hand. So we recommend that if you're doing microservices and containers, you adopt a DevOps, actually you develop a DevOps culture within your company. Because truly DevOps requires a culture change. If everybody isn't participating, and I mean everybody, not just the dev group, not just the operations group, even if you're doing DevSecOps, not even just the security group, even those three, it's not enough. You need everybody participating in this environment. And the goal, as I mentioned before, is to achieve continuous delivery. You're continuously deploying and delivering your software with the ultimate goal of achieving continuous improvement, both in the software itself and in the products and services it's meant to support. There's no argument against continuous improvement. So I want to just briefly go through the most fundamental model of a DevOps process. Okay? And it starts, of course, with the developers producing code. They're producing the code that runs the software. And we're going to put it in containers as microservices, and we're going to process it across the network that way. But before we can, the operations team needs to come in and deliver and deploy that software. So they've taken the developed code, delivered it, deployed it, and now the users get to do what they do. They do their thing, and they use the software. As they use the software, they're pretty immediately going to have some reactions to it. So operations comes right back in and collects their feedback. They then take that feedback and bring it to dev, to the development team. The development team then improves the code based on the feedback. They create a new version, which is then given to ops to deploy and deliver, and the users then use the new version. Ops collects their feedback, brings it back to dev, and what happens is that this cycle is basically repeated over and over and over and over again. In some organizations, this cycle is repeated as many as, dozens, maybe even hundreds of times per day. Per day. This is not your 6-month, new revision, new version release that everybody has to patch and deploy. No, this is happening every couple of minutes, every hour maybe. And it's constant iterations of improvements to the software. This is why everybody has to be involved. Because for this to work, everybody has to participate enthusiastically in their portion of it. Sure, the developers have to develop quickly. The operators have to operate and deploy and deliver the software quickly. Security has to make any necessary adjustments to the security provisions quickly. But the users also have to quickly adopt and use the software and quickly provide their feedback to operations so they can get that back to the developers for the next iteration. The faster this happens, the more improvement you have, and the more you're achieving your constant improvement. CI/CD, constant improvement through constant delivery, is a magical goal. We build pipelines around it. And here's where that rubber meets the road. Using microservices and containers and securing that to make sure that it's as efficient and as effective as possible. Hopefully that gives you a better picture of why microservices and containers. And John, if we have any, I'd love to field some questions.
We do, my friend. Let me see here. Let me just remind everyone that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. We've got several here. This is got a couple of nice compliments. That's great. Here's one. You didn't mention any specific products. Are there specific ones we should be using?
Yeah, this actually is a constant question. It is inappropriate for me to suggest specific products. For one thing, you're probably engaging somebody to give you that kind of advice, and I don't want to conflict with them. Really, I mean, most of us have heard of the most popular orchestration products, the most popular image packaging products. They've been out there and they've established their preeminence over a long period of time. But you'll notice that I didn't even mention our sponsors product in today's presentation. I don't do that. And I haven't made anybody mad.
Okay. Boy, the compliments are really coming in today. Okay, here's one. How will we see software like this showing up in the market?
Do me a favor, repeat the question. I didn't get all of it.
Sure. The question is, how can it be, oh no, I'm sorry, wrong question there. When will we see software like this showing up in the markets?
Software like this is already showing up in the market. Okay. Some of these tools, I mean, a lot of the tools are open systems tools, right? They've been developed by the community, and they're contributed to by the community. So they get the best of all developers. And there are some organizations that their business is supporting those things. So, you know, I think there's a robust community out there. I do think, however, that as the foundational technology, the container technology, continues to develop, all of the subsequent technologies improve. And so you'll see that emerging on the market. And basically, you need to align yourself with somebody whose job is to stay on top of this stuff and can be your resource, your consultant. Either that, or if you can do it yourself, God bless you. Go for it.
Okay, here's one that I actually kind of hear in various forms with regard to containers. How can it be that developing applications in little pieces is better than keeping it all together?
There's a concept, and I think this is the best way to explain it. There's a concept called loose coupling, as opposed to tight coupling. In tight coupling, anything impacting one thing will subsequently impact other things. So, for example, in a monolithic software product, if something happens to a routine and it locks up, well, if it's tightly coupled with all of the rest of the software, so the entire application can lock up. And then you've got a bunch of people sitting around twiddling their thumbs. That's not good. In loose coupling, where each one is pretty independent, as I described here, each microservice is, and in its container, the container is created when it's needed, not any time before. It's not like they're sitting in inventory. It's created when it's needed, and it's immediately scanned to make sure that it was created correctly. If there is a flaw, it's destroyed and recreated, reinstantiated. And that new one, which now proves to be okay, moves along. Nobody notices that happen. It happens too fast. The rest of the application is going along merrily because each microservice is loosely coupled from each other microservice. And that's why this microservices approach is so magical, because you don't ever have to worry about bringing down the whole shooting match. It's a whole different definition of resilience.
This is fascinating. Okay, so this one follows logically. Should we use standard security products to scan and protect, or ones designed specifically for containerized environments?
And my answer is going to be yes. First of all, a network is a network is a network. That is to say that the network itself should be protected properly from a foundational standpoint. As you're moving into microservices and containers, yes, start looking at products that are specifically designed to support what you're doing. That is no different from anything else you've ever done. You should always be looking at products that were designed for what you are doing, because there are brilliant entrepreneurs who are realizing needs all the time. And they go out and they create whole companies around the idea of solving that problem for you. Why wouldn't you want to take advantage of that? So I'm a strong believer that, yes, have a fundamental, foundational security platform that you can depend upon for your overall network operation, even if it's all cloud-based. But also start to look at those products that will support your microservices, your cloud-native operation.
Fascinating. I think that's about all the time we have. Would you do me a favor? Would you just redefine cloud native for me? I hate to be the dumbest guy on the podcast today, but just that definition was great, and I'd love to hear it again.
Basically, cloud native is pretty simple. It's software designed specifically for the cloud. That is to say, instead of being created all as one big block of code, it is broken down into its component parts. So each part is a microservice, one function or one operation that needs to be done somewhere during the use of the software. These microservices are packaged into containers that can be transported instantly to wherever in the cloud network they're needed, to whichever cloud location they're going to be best performed at. And therefore, since they're each a small component, loosely coupled from the others, none of them can bring down the entire operation. You're insulated from that. And this takes advantage, fullest possible advantage, of all of the characteristics of cloud computing.
Thank you, Howard.